Hello, welcome to Statistics and Mathematics YouTube channel. Today we are going to start our studies on group frequency distribution and then on group frequency distribution. Now, our last two videos, we talk about the clear distinction between the group frequency distribution and then on group frequency distribution. So it will be of your own benefit to go back and then start watching the introduction to frequency distribution for you to really get the clear distinction between the group frequency distribution and then on group frequency distribution. So basically, we are going to start with the group frequency distribution, and then here we are going to use an example for us to know how to construct a group frequency distribution. So this is our first example. It says the data represent the recorded high temperature in degrees for each of the following 50 states. Construct a group frequency distribution for the data. So this is the raw data being given to us. This is our raw data being given to us. Yes. So please, the ones that are circled and then cancelled out, we are going to use it. So it is part. So don't just assume that it is not part. It is part of the raw data. So we are surely going to use it. You see, the question it has just tells us to construct a group frequency distribution for the data, right? So for a group frequency distribution, here we have to get our class intervals, right? Will be on one column, our tally will be on another column, and the frequency will be on what? Another column. So for us to be able to get the intervals, right, the groups within which some of the observation or the raw data will be included, we have to first learn how we can just get this class intervals or this class group. So for us to get these groupings, you see, in some questions, the grouping will be given to you, whilst in other questions, the grouping will not be given to you. So if the grouping is not given to you, you have to find the group yourself, right? You have to learn how to construct the intervals yourself. So here we are also going to learn how we are going to construct the intervals ourselves if the interval is not given for the group frequency distribution. So the first thing that has to come at the back of your mind is how to calculate for what? Your class width. And then we could see clearly that the class width is equal to h minus l divided by k, where the k is the number of what? Classes. And then our h is what? The highest value that we have in the raw data, and the l is the lowest value that we have in the raw data. And the largest value that we have in the raw data is what? 134. And then the lowest value we have is what? 100, right? But we don't have our k. The k is the number of what? Classes. So how are we going to find the k? That is the number of classes. Yes. So our k is equal to 1 plus 3.322 times log of what? N. Right? So here we have 1 plus 3.322 times log of what? 50. You see, the n here is what? The 50. That's the number of what? Observation. So here I'm going to count all the observation here, right? And so we can just count 1, 2, 3, 4, 5, right? And I just count this what? The column. Let's count the row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see clearly that 5 times 10 is surely going to give us 50. And in most cases, the n is surely given in what? The preamble given to you. The preamble that is attached with what? Raw data. And then we could see that here is what? 50 state. Of it, the n is equal to what? 50. So here, we are just going to substitute wherever we see, and we are just going to substitute what? 50. So here, we are going to have 1 plus 3.322 times log of what? 50. When we add everything, we are going to get 6.64. So since we want our class, our number of classes to be in what? A whole number, we are just going to run this one to get k is equal to what? 7. K is equal to what? 7. Right? And then one thing you have to remember is that for these cases, you see, we learned in our basic school that when if you have a decimal place and then you just want to run it to a whole number, and then we have, if the digit lies between 0 to 4, we are just going to leave the whole number just like that, right? But if it is more than 5 to what? If it's more than 5 and end at 9, we are just going to add 1 to what? The whole number, to increase what? The number, right? So here, this rule doesn't work when it comes to finding for our k. So if in case we calculate for our k and we get 6.17, we are surely going to, if you run it to a whole number, we are surely going to get what? 7. right? We are not going to what get 6. So that rule doesn't work when it comes to when we are calculating for our number of what classes. So put it at the back of your mind, because you are going to use it in these videos a lot, right? So here we have our k to be 7, we have our a to be 134, we have our l to be what 100. So here our class width is equal to what h minus l divided by what k, which will be given as 134 minus 100 divided by what 7. And when you simplify it, you are going to get 34. When you simplify it, you are going to get 34 divided by what 7, of which you are going to get 4.86. When you run it, you are going to get what 5. So this is what our class width. This class width is surely going to help us to get what our class interval, right? Yes, it's surely going to help us to get what our interval, right? So here our intervals will be within what temperature, right? That's the degrees. It was in the question. We learned from the question that the data represent what a high temperature recorded, right? So here our interval will be equal to what the temperature, right? And then when we look through the raw data, right, we have to spot our least value, and then our least value here is what 100. So what we are going to do is that we just write our least value here, that is 100. First, let me clean this one so that we will do it together for you to really understand what we are doing in this part. Okay, yes. So first, all that you are going to do is to get your list number from the raw data, and our list number here is what 100. As you can see here, our list number here is what 100. So we start with 100, and then we get our class rate to be what 5. So we are just going to add 5 to 100. We are going to get 105. When we add 5 to 105, we are getting 110. When we add 5 to this, you are getting 115. When we add 5 to this, you are getting 120. When we add 5 to this, you are getting 125. When we add 5 to this, you are getting 130. When we add 5 to this, you are getting 135. So all these, as you can see here, all these are called what the lower limits, right? So since they are going to lie within a group, we have to get what our upper limit, right? So here we have to get our upper limit for this. We have to get our upper limit. Yes, we have to get what our upper limit, right? So what you are going to do is that we are just going to subtract 1 from our width. When you are surely going to, for all these cases, if you want to calculate for your upper limit, right, all that you do is just, when you calculate for the rate, you just subtract 1 from what the rate. So here we have 5 is the rate, so you just subtract 1 from it to get what 4, and then just add it to what the lower class limit of each level to get what your upper limit. So here we are just going to add 4 to 100. We are going to get 104. When you add 4 to 105, we are getting 109. When we add 4 to this, you are getting 114. When we add 4 to it, we are getting 119. When we add 4 to 120, we are getting 124. When you add 4 to 125, you are getting 129. When you add 4 to 130, you are getting 134. And then we are not going to add 4 to 135 because our largest value in the raw data is what 134, and then it ends here. So this is where you are going to end. So the next is, what you are going to do is just to go to the raw data and then just check the number of individuals or the number of values, right, that lies between 0 to 100, right? So when you do that, you are going to record what 2. So let's go and do that. So when we come here, we just have two observations. So let's look through. When we come here, is there any number that lies from 100 to 4? No. 100 to 104? No. But we have one here which is 100 that lies we have this one that lies within 100 and then 104. So let's continue to go through. When you continue to go through, let's see if you get another one again, and then let's see if you get another one again. When you go through one by one, let's go through one by one. Let's go through. Yes, and then we are having this one here, right? We are having this one here, right? So this is 104, right? We have 104. So we are having just two observations, right? Two individuals that falls in there. So we just come here to the frequency side, we write 2, and then they tell you just mark 2, right? As you can see here. So let's see the individual observations, right? That lies between 105 and 109. So the individual observation, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 observation. I'm sorry, I did a mistake here. That is 8. We are just going to clean it to get here to be 8, right? We are going to get here to be 8, and let's count the observation that lies between 110 to 114. So when we come here, 110 to 114, right? We are just going to count, and when we count it, let's start from here. We are getting 1, 2, 3, 4. Let's continue. 4, 5. Let's continue. 6. 6. Let's continue. 6, 7. 7. 7. 7. 7. 8. 8, 9. 9. 10, 11, 12, 13, right? 14, 15, 16, 17, 18. 18 observation, right? So here is 18. You have here to be 18, and then we are going to count from 115 to 119, right? So when we come here to, we are just going to write the tally. So this is 5, 5, 5, and what? I'll add another stroke to this one to get what? 18, right? So this is how it will go, right? And then for that one, when you count, you are surely going to get 13, right? As you can see here, because of time, let's count it and then reassure that in the comment section that we had 13, right? So 115 to 190, you are going to get 13, right? And then 120 to 124, you are going to get 7. And then for this one, you are going to get 1, and then for this one, you are going to get 1. So this is how you are going to construct the group frequency distribution when a raw data is given to you. I hope you have really understand what we are discussing here, right? So let's continue. For the ungroup one, you see right now we have learned how we will do for the grouped one. So let's come to what? The ungroup section, right? So for the ungroup section, we use the ungroup frequency distribution. First, when our class rate and then our number of classes is very small, right? Yes, when it's very small, right? The class rate, the number of classes, and the range, right? If it is very small, we opt for what? The ungroup frequency what? Distribution, right? So as you see in our previous as you see in our previous example, we saw that there was some cancellation that I told you they are all part. For this one, they are part of it, right? So don't just assume that they are not part. This is 12, 12, 12, 12, and this is 19. They are all part of what? The raw data. So you are just going to use the examples here to really understand what the ungroup frequency what distribution, right? So here it said the data shown here represent the number of what? Miles per gallons that 30 selected 4-wheels drive sport utility vehicles obtain in what? A city driving, right? Construct a frequency distribution and analyze the distribution, right? So this is what we have, right? So this is what the raw data, and then we have to construct the frequency distribution for that, right? So first, when it is given to you, as I told you, first thing that it has to come to your mind is to get what? Your class intervals, right? But sometimes you see that the class interval is too small. So when it comes in that way, we just use a single digit to represent that class interval. So whenever you use a single digit to to represent the class interval. This is called what? The ungroup frequency distribution. It means that the class interval doesn't lie between a given what interval, right? It's just assuming what? One single what? Point, right? So here, what you have to do first is to just calculate for what? Your class rate, right? So for the class rate, what? The h minus l divided by k, as you've seen above, the first example you saw. So here our h is equal to 19, our l is equal to 20, and you have to calculate for our k. Because when you go to the this raw data, you saw that our h is equal to 19, that's the highest value, and our smallest value is what? 12, right? So you have to calculate for our k. We just have to write 1 plus 3.322 times log of what? N, right? And then when you have this one, when you punch this one on the calculator, I'm going to get 5.907, right? 5.907, of which here our k is equal to what? 6, right? So we have 6 to be what? Our number of what? Classes, right? So once we have the k, we have h and l, we can find what? Our class rate. So when we find our class rate, it's surely going to be 19 minus what? 12 divided by what? 6, right? And we are going to get 7 divided by 6, and then our final answer will be 1.16. And then you see, I told you that when you are doing for the class rate and then the number of classes, right? If you have 1.6, if you have any let's say if you want to run it to a whole number and then just lie from 0 to 4, we just add 1 to what? The whole number to increase the number, right? So here we just add this 1 to it to get what? 2, right? As I've explained what? Earlier, right? So you can see that the class rate is very small, right? The class rate is what? Very, very small. So what we are going to do here is we are just going to, since the class rate is very small, we are just going to use what? The individual numbers that we see there to represent what? The class interval, right? So when we come here, we see that we have 12 inside, we have 13, we have 14, 15, 16, 17, 18, and what? 19. These are the individual observation that is just repeating themselves. So when we come here, 4, we have 12 here, 12 is repeating itself inside, we have 13 here, we have 17 which is repeating itself inside, right? We have 13 which is repeating itself inside, 12 repeating itself what? Inside, right? So that one will represent what? The class interval, right? So here, as you can see, here is 12, 13, 14, 15, 16, 17, 18, and what? 19, right? So here when you go to the table, 12, right? You are just going to count the number of times 12 repeat itself, right? So when you come here, you are just going to count them, right? We have 1, 2, 3, 4, 4, right? 5, and then we have another 12, right? We have another 12, right? So let's count it. When you come here, you have 1, 12 here, 2, 12, right? 2, 12, 3, 4, 5, and then we have 6 12s, right? So when you come here, we have 6 12, as you can see here, and then we just write the tally: 1, 2, 3, 4, 5, and then 1, which is what? 6, right? So let's count the number of times 13 occurs, right? So when we come here, 13 is just occurring once, as you can see here. 13 is just occurring once, right? So we come and write 1 at the frequency, and then just write 1 stroke here, 14. How many times is 14 occurring, right? So when we come here, 1, 14, 1, 14, 2, and then 14, 3, right? So 14 is just occurring 3 times, right? 3 times. So when you come here, write 3 at the frequency section, and then write 3 stroke at the tally section, right? So when you continue, we see that 15 is also having 6 observation, 16 is having 8 observation, 17 is having 12 observation, 18 is having 3 observation, and 19 is having what? 1 observation. So this is how the ungroup frequency distribution is also constructed. So right now we have learned how we can construct the group frequency distribution and then ungroup frequency distribution. In our next video, we are going to discuss how, when we are given group frequency distribution, when we are asked to calculate for the class boundaries, the class midpoint, the cumulative frequency, and then many more. How we are going to calculate for that. So please kindly make sure you subscribe, like, and share, so that when I upload that video you can see and then watch and you'll be blessed. Have a blessed day. Bye.